Right. Hello. Um, so, um, I had some thoughts. What did I do? Hello? Oh, that was system audio. What the hell did I click? Oh, whatever. Um, like, this is a lot of fun to play with. Mm, and after, like, just iterating on this, I had some clearer concepts in my head that I wanted to apply to kind of have, like, an actual architecture of this thing. So, yeah, so one thing I did add was, let's see. Yeah, exactly. Anyways, where should we start? Yeah, I'm not gonna like reiterate on everything we did. A small thing I did was I added like memoization. It's very interesting. You know what? I'm gonna just delete everything here so we actually have something simpler to work on. Let's see, app. There isn't anything here. Let's just do state, create state, and then state.count, and then on click state.count plus plus. Okay. So what I did add is that these, I'm actually calling these things something now, because this is like a reactive scope, but it's as a JSX child, right? So I'm calling this a reactive child. So this is a reactive component. This is a reactive child. And then you have reactive attributes, like color, count, state.count % to red, blue, for example. So that those are the reactive concepts. And with that, I kind of saw more of a clear architecture. So I thought we could just go through that architecture, and then I haven't read this. So let's see. So what do we have here? Core concepts, reactive proxy system, component architecture, observation scopes, memory management, dynamic content transitions, module organization. Okay, so fine-grained reactivity. Unlike React's component-level updates, UI Lib uses fine-grained reactivity that updates only the specific DOM nodes that depend on change state. This is achieved through proxy-based state tracking, dependency tracking, granular updates. Component functions execute only once during their lifetime. They don't rerun on state changes. Instead, reactive scopes, function children, and props create observation contexts that automatically track and update. Yeah. So that's what we're seeing. Well, it's basically what I did. And then the reactivity system uses JavaScript proxies to create observable state object. This is implemented here. How it works. Create state, blah, blah, blah. Yeah, you know this. Global scope tracking. The reactivity system uses two complementary global scope trackers. Observation scope. So that would be like when we're executing these observation functions. That's like the current observation. And then we also have current component. Dependency tracking. The system maintains several weak maps for tracking dependencies. Property listeners maps objects to their properties and properties to computations. Yeah, so that would be... Oh, this is called computation subscription. We should change the name of that. So property listeners is basically the... like when we have reactive properties and computation subscriptions. Yeah, I need to change the name of it, but that's like when it's a child, right, in the JSX. And proxy cache, so this is like when create state. So I'm just going to try to explain, like, let's see if I understand this implementation. So proxy cache is when you implement a proxy, you typically do this like lazy creation of proxies. So as you start traversing into the object, you create proxies lazily as you dive into objects. And you don't want to create new proxies, right? You want to have a stable reference between the object and the proxy. So you have to cache these proxies related to the object they represent. And then array mutations are handled specifically. You have to do that. Batching, multiple state changes can be batched. Each batch increments a global change counter, and this is used for memoization so that when reactive child scope, yeah, maybe I should change the name of this. Anyways, a reactive child scope evaluates, it can look at its the change count. Like, is the cached value the same change count as the change count I'm running now? If so, use the cached value. And then it's the component architecture. The library maintains a logical component tree parallel to the physical DOM tree. This architecture uses two internal instance types defined. So we didn't do this before. We just used the DOM nodes as kind of the truth. The problem with that is that we need to manage subscription, like listeners, like event listeners. We have these reactive scopes and so on and so on. And instead of trying to, like, the challenge is to clean up. So to more efficiently be able to clean up things and have control over like the boundaries, like we have an actual reactive component and we have something called a reactive child. And these hold all these like specific to the library. So it holds a reference to its parent, any reactive instance, which would be like a reactive component or a reactive child, so that if this is unmounted, right, you can just clean up the whole thing very easily. Cleanups, that's a weird name. I think this is event listeners. Oh no, it's on cleanup, sorry. Yeah, I do wonder where the... Yeah, I wonder if that's how it deals with the event listeners. It puts like an on cleanup on them. Yeah, I need to check that. Tracks children, manages lifecycle, owns cleanup responsibilities, event listeners, autoruns. Yeah, I wonder... I'm gonna check that. I don't quite understand that. How does... Yeah, let me put Claude back in play here. Let me make it a bit bigger. So exactly how does the reactive component manage event listeners on, like on-click event listeners on DOM elements? Like how does it track them and how does it clean it up? Oh. What happened here? Hello? I think I muted something. I hit this button. Yeah, look at this. But did that also mute the microphone or? Oh, what did I do? Hello? I have no idea what's happening here. Ah, this sucks. Whisper. I think I might have clicked something. Hello? There we go. Could you please explain to me how a reactive component is able to track any on-click listeners on the elements of the component and how it's able to clean them up? Okay, we're back. Anyways, yeah, so I'm actually a little bit unsure. This is so complex. Yeah, and we'll get closer to it. Parent-child registration. Parents during construction does not auto-register with reactive child. Parents, manual registration. Yeah, because there was a bug here. Yeah, so when a reactive component is constructed, it will register itself to the parent, like the current active component or current active parent, but it does not do it with reactive child. And that is because, why is that? Yeah, we have to look at that. Okay, let's see how this actually works. When you write something like this, the setProp function handles the onClick prop. Yeah, onClick, and then it goes in, adds the event listener. Yeah, and then it adds it as a cleanup. Oh yeah, of course. So the thing that I'm like constantly mixing up is static rendering and dynamic rendering. So when you do something like this, it's static, right? So oh, what happened? It's static. So the only time you really want to remove this is when the component actually unmounts, right? So that's why you can use an on cleanup. But yes, similar reactive child used for reactive JSX children also has cleanups. When a component is disposed, I remove from DOM or parent. The dispose method runs. Yeah, and this just cleans up all the children, its own things, everything. Yeah, and then the thing is like, we're gonna go to that now. Okay, so we didn't quite answer this one, but let's see. So this represents reactive scopes created by blah, blah, blah in JSX. And then it's kind of the same, but it has different logic. So this is only created for reactive JSX children, not for reactive props. Manages dynamic DOM content within comment bounded regions. So we're using comments to create regions of this dynamic behavior. Provides cleanup context for intrinsic elements inside the scope. Handles smart diffing for key. So this is like basically managing the dynamic nature of the UI. So like you might, based on some state, you might return like an element with an on click, but then if the state changes, maybe you return null, right? So then you need to clean up the element. But you might also go from one element with on click to a different element with a different on click, right? Stuff like that. And then you might return an array of elements that might have keys, and it should efficiently like update things and clean up the right stuff and everything. So it handles a lot more stuff. So what you see in the tree is like reactive component, and then a reactive component might have a reactive child. I'm not sure what it means by cleanups here. Yeah, but then reactive child might have an array of reactive components, for example. Parent-child registration flow. When a reactive component is created with another reactive component as parent, it automatically registers itself during construction. This is safe. Okay, here we come to the... This is safe because component render is deterministic. When a reactive component is created with a reactive child as a parent inside a reactive function, it does not auto-register. Here it explains it. Let's just remove that. Let's remove this. Yeah, does not auto. Why? Reactive child runs an auto-run that disposes all current children at the start of each evaluation, re-evaluates the function, adds the new children to the set. If components auto-register during step 2, they would be in the children set and immediately disposed. Yeah, it's because it disposes, right? So it needs to know what the new children are before it can dispose of the old children. That's basically it. Yes. And then it does a lot of stuff, as I mentioned. We can test this. This is the thing that's like the most complex part of the anything really. It's like how to efficiently manage dynamic UI. So we can test and see if it works. Function, children, and props create observation scopes that automatically track dependencies. There's function children, function props. Then we have DOM regions. Reactive children use comment-bounded regions in the DOM. Proper cleanup prevents memory leak through a hierarchical disposal system. Reactive component tracks all cleanups, auto-runs, and event listeners. Reactive child manages this region auto-run and child component lifecycles. When a component disposes, it recursively disposes all children first. Event listeners are automatically removed. Reactive subscriptions are automatically disposed. DOM nodes are removed from the tree. Oh, cleanup example. Yeah, when toggled to null, reactive child disposes the old. Yeah, so this is a reactive child. Disposes all content. Child component dispose is called child. Event listeners are removed. Child's reactive scopes are disposed. No memory leaks. And then subscription cleanup when a computer. Yeah, so let's go in and actually fix this. Oops. Yeah, we're calling it. So we have a concept called computation here, and I'm not quite sure what it's referencing. Could it be that it's now actually referencing like the reactive prop scopes? Please explain. Yeah, because I want to have like, and this is very interesting. Like this is a complex implementation. And if I were going to do this manually, I would never get anywhere. And the point is to actually have something working. So, but what's interesting to me is that even though the implementation is complex, I'm trying to extract like conceptually, like what's the conceptual abstraction here? What's the naming? How does things flow and all this stuff? And this is a new experience for me using AI, where it really does the grunt work of the complexity. And then I'm only focused on conceptualizing how things fit together. So let's see what it says here. Yes, you're exactly right. Looking at your code, computation refers to any reactive scope created by autorun. And in your current architecture, what is a computation? A computation is defined blah, blah, blah. It's an object that has a run, cleanup, what creates yeah, reactive props, reactive children, to create a computation. Okay, it references all reactive scopes, including reactive prop scopes, reactive child scopes. Okay. Okay. Oh, wait. Okay, so I don't think computation is the right term here. Rather use the term reactive scope. Please update the code and related documentation for this. Okay, so that was confusing to me. A computation is just a reactive scopes, and reactive child is a specific type of scope, and maybe we should also have like a reactive prop, which also uses a reactive scope, right? But it doesn't need like the cleanup and stuff. It's a more pure concept, but I think we should add it just for like what types of reactive scopes do we have? We have a reactive prop, we have a reactive child, and we don't really have anything else at the moment. Maybe something else will pop up. Yeah, and then we have event listeners, dynamic content transition. Yeah, so this actually shows all the... So you have these dynamic transitions, right? You might go from an element to no element, from an element to a different element. You might go from a component to an element. And here the strategy is to clear all content, insert new content, right? That's how you keep the DOM updated. But then you have array transitions. So if it returns an array with non-keyed elements, it does the same thing, right? It just replaces all the elements, cleans up, and then adds the new elements. But when you have keyed arrays, either the element has a key or the component has a key, then it builds a map of all items by key from both reactive components and DOM nodes. And then it removes items with keys not in new array, and it reorder inserts items based on new array order, and reuse existing DOM nodes where possible. And the good thing here is that it doesn't need to... Yeah, we need to ask it about that as well. Because the good thing here is that even though it's gonna like produce the how do you put it? Like the virtual DOM. Like when I say virtual DOM, like React has a virtual DOM, which means that anything active in this, like it constantly has a representation of the current DOM. This is not true here. We just use the object description of the DOM using JSX to produce the DOM. But after that, it's gone. So that also means that if we return a list of components, we don't actually create the components and kind of unwrap them. Because if we already have that component keyed, we're going to just keep using that. There's no reason to update it because there's no like props updating or anything like that. That's just how reactive systems work. You don't have to do that stuff. Key diffing, yeah, so the key diffing algorithm handles both component instances and intrinsic elements. So it builds the old map, collect reactive components from children set, scan DOM region for keyed intrinsic elements. Yeah, I'm a little bit curious if this is as optimal as it used to be now. But it disposes reactive components no longer in your array, remove intrinsic DOM nodes no longer needed. iterate backwards through new array, reuse existing nodes where possible, create and insert new nodes as needed, maintain correct order with insert before. Okay. Yeah, I guess that's it. But great. And now I actually also want you to introduce the term reactive prop, so that we have like reactive scope is a low level primitive, but then we have reactive child and reactive prop on top of that. And that of course is used by the current like props logic, which is reactive. And I guess it's like a very shallow abstraction, but it's nice to have the term there. Please update the documentation as well. Did it actually update this? Oh, what did I do? Oh, there we are. Wait, what's happening? Oh, Ecamm live program. Oh, there we go. Sorry. Yeah, okay. So we have that in place. And then I want to look at, yeah, let's actually play around with that dynamic stuff. That would be fun. And we should have like a list of to-dos here as well. And let's give it an ID. Actually, give it a number. Description and completed. Yeah, let's just give it a chance to update this. But what we're gonna do is, because as I said, this is the really tricky part. It's the dynamic content. How can we efficiently test this? Like we have tests for everything, so those would be broken if it didn't actually work. But let's see, DOM. So these are like regions. Yeah, because what it's not quite clear to me is when it's doing this array diffing, it's a children's set. Yeah, it just keeps from children's set, but does it keep the, what is the remove alt keys? So there's a map of key, and I guess it would be the element or component reference. I want to look at that logic. Okay, I think this is probably good. This was just some renaming stuff. Nice, layered architecture. So could you please go to the logic which manages arrays and key diffing? I want to really understand that code. So please show it to me and then explain it to me. Yeah, but this is pretty cool to have those clear concepts. Yeah, and I'm also reflecting on like, what's the next, what's like missing here? And it's like context is missing. Yeah, Adam and me talked about like suspense boundaries. Like what you can do is like you can make these async. And then it throws to a suspense boundary, which is interesting. And then I would want to have like create query and create mutation and create mutations. Because I think those two primitives like truly reflect what async really means at a higher level. So you get like all the bells and whistles you need to reflect how they operate in the UI. And then you have like error boundary. Like there's a concept of portal. But again, it's like, yeah, I'm trying to reflect on what the intention is with this thing. I think the most logical thing to do is to get it to like the core feature set so people can actually play with it, and then write like an article, and that's it. And then if someone would like pick it up and get excited, like then that would be really cool. But if not, like I'm in no position to do this. Like push the project forward. Okay, let's see what it says. Perfect. Now let me explain the array and key diffing logic. The core logic is in the append child function, specifically in the key diff section. Yeah, exactly, because we created this keyed item. So when you write div key foo, the JSX doesn't immediately create a DOM node. Instead, it returns a keyed item object that delays evaluation until something something. I can't see it. Oh, there we go. Oh, wait a minute. Wait. For fuck's sake. When you write, oh, here we are. That until, okay, that delays evaluation until the diff algorithm runs. So if key is not undefined, it returns a keyed item. So this happens in create element. If an element has a key prop, it wraps everything into a keyed item instead of immediately creating the element. Okay. The diffing happens inside the auto-run callback within append child when the child is a function. So when it's a reactive child scope. Here's the step-by-step process. Build the old key map. Okay. The algorithm builds a map of existing keyed items from two sources. Reactive components from the children set. Child instance DOM roots. Yeah, I wish it could use like instance of here instead. But okay. This captured keyed components like my component, key foo, and then keyed DOM nodes from the region. Yeah, so this is where I'm a little bit confused because it seems to, when it's looking through DOM nodes, it's looking through the region. It's not looking through this captured key. It also identifies non-keyed nodes for removal. Okay, so there's another complexity. It's like maybe some nodes are keyed and some are not, which shouldn't happen. So I think we can make this better. So remove non-keyed nodes. Yeah, and then it removes them. Before diffing, remove any non-keyed nodes that were mixed in. That shouldn't happen because that should actually throw an error. Okay. Remove deleted keys. DOM removal. Yeah. If a key exists in the old map but not in the array, remove it. Yes. Reorder insert. This is the clever part. It iterates backwards through the new array. Yeah, and then it just goes and grabs the old key. Existing node. Yeah, so it's actually using... Okay, so I think the issue here is really that... okay, let me see if I can explain it. Okay, so one thing I'm curious about here is that we currently allow mixed elements or mixed children with and without key. That shouldn't be possible. Like either all children are without a key or all children are with a key. So you should throw an error if there's a mix. No, you shouldn't do that. You should allow that. Or wait a minute. Thinking. I guess React allows that, does it? Oh, yeah, this is interesting. Like, can you have that? Yeah. Oh, that's interesting. I'm gonna ask ChatGPT about this. Does React allow you to have a mix of keyed and non-keyed children? Yeah. Strongly discouraged. Yeah, I think we should try to throw an error there. Yeah, let's try to do that because it doesn't make any sense, I think. So since it throws an error, I guess we don't need to go through the region anymore. Like our map has either references to components or it has references to DOM nodes, right? So does that make sense? No. Hey, that should not be possible. That should... Didn't I say that? That should not be possible. That should not be possible. Okay. That should not be possible. Like either all children are without a key or all children are with a key. So you should throw an array if there's a mix. Yes, that makes perfect sense. You're absolutely right. Let me trace through the logic. And you're right about the simplification. If we enforce this, then we know all the items were keyed, so we don't need to scan the region for non-keyed. Yeah, exactly. Yeah, so I think this is a good example of like working conceptually about something and not actually writing the code. Because especially when you work with complexity, you want to understand things at a high conceptual level primarily, and then you don't, and that's always what happens, right? If you implement something complex, when you leave it for a while, like the thing that sticks in your brain or should stick in your brain is how it works at a high level. And then you can dive into the code and you can like bring back, oh, this is what I was doing here and this is what I'm trying to do. you don't have to remember the code. It's interesting. I'm having so many like back and forward reflections about using AI. But yeah, again, I would never take on a project like this or an experiment like this without AI. Validation added now throws an error if you try to mix keyed and non-keyed children in the same array. Simplified keyed diff. Remove the non-keyed nodes, blah, blah, blah. Benefits clear semantics. Either all children have keys or none do. Simpler code, no need to handle mixed scenarios in the diff algorithm. Better error messages, more efficient. No need to scan for and remove non-keyed nodes during key diffing. Please add a unit test or a test case for this, or review the tests and make sure we have a test case for this. Okay, cool. And it's still working. Nice. What to do now? What would be the next step? I guess it would be like a proper code review to see if there's nothing weird going on. Yeah, I think we need to, well, it isn't much code. That's the crazy thing. It's very clean. It's a little bit, I'm not sure about this DOM file. Yeah, so we have reactive child. Does it have a reactivity? Auto run with memo. Oh, I think we have some duplicate stuff. Okay. And then yeah, no, you know what? I think I should just in the background. Wait, we can actually do this now. It will be nice to get to good state. Oh, yeah, we should just make it go through and review all the code and remove any like duplicates, unused parts, and then also comment based on, yeah, basically comment. And then I want to push that, and then I want to write that article. Because it would be fun to like explore, like, okay, let's put context in here, let's put suspense in here and all of this, but like that's simple compared to what we've been doing here. This is kind of the threshold for, yeah. Hi there. Hope you're doing well. I'm doing well. Long story short, I've been interested in the tech side of things. Currently one top, and decided to get my feet wet in data analytics. No, no worries. I'm here to hang out. Data analytics. Yeah, advice. Yeah, I haven't worked much with data analytics. What I do think though is, well, the experience I do have is like someone who's deep into data analytics and isn't able to explain it to other people isn't a good data analyst. So you should be as concerned about communicating the results you're finding as being good at finding results. So you kind of have to be, in my experience, a data analyst should be a mix of like technical, like doing the analysis, but also being almost like a product manager. So you have to understand the product as well as the data underneath so that you can make the connections, the important connections. And then you have to communicate that really well to like the team, to the company. So I wouldn't just go. So if you want to learn about data and analytics, I would also learn about product management. So not product management in the sense of like, well, maybe product management is a wrong wrong analogy here, because you wouldn't report necessarily to. No, I want to stick with that. So I would dive as hard into product management as data analytics, because that's the role you're going to have. It's like but a product manager takes the goals of the company and translates that into like actual features, right? But as a data analyst, you have to take the goals of the company and translate that into relevant data analysis and then report back, just like a product manager working on features reports back. It's a very similar role. And the reason I'm saying this is because I do have experience working with data analysts that aren't very good at communicating the results and connecting the dots for people. Like, because analysis can be very overwhelming. There's a lot of numbers, and being able to like dissect and package that into something that's very easy to comprehend, that's a true skill. So yeah, I think that's the advice I would give. So whatever your method of learning is, going to school or watching videos or joining courses, do data analytics and project management. I hope that made sense. Okay, great. And then please review the code and identify where we have duplicates or code that we're actually not using, and also comment complex pieces of logic that reflects the architecture and the flow of the library. Yeah, I'm noticing I'm not 100% today. I was talking to my partner. It's insane. Something's happened to my brain as of late. I'm noticing when I'm typing. So when I'm typing on Slack, I'm as normal, I'm thinking about what I want to say. And then I look at what I'm writing and I'm like missing words. And it's so weird. I never used to have this problem. I was like a very excellent typer. But for some reason, words are just missing when I'm typing. And sometimes I have other words than I was thinking about. It's really weird. And but my partner said she's had it like this for a long time, but I haven't. I've been so in sync with my fingers, and I'm wondering if it's because of AI. I'm not writing much code, at least not as much as I used to, and I'm wondering if I'm just out of sync, my brain and my fingers, because they're not practicing as much. It's very interesting. And my partner told me that, you know what, I'm just typing. I don't care if I make mistakes. I'm just dumping it into AI and it cleans it up and then it's good. And it's interesting because the bandwidth of like brain to keyboard is very, very narrow, right? It's a really shitty way to communicate with a computer. So yeah, but I was a little bit, it was kind of part of my identity to kind of be able to just like flush out what's on my mind using the keyboard. Yeah, I do wonder if this is like where some of the AI anxiety is coming from. It's like we feel very, as engineers, we feel very comfortable communicating within the rule set of code. And we identify with like being efficient coders, like typing fast and kind of be in sync with our brain, like all of that stuff. But when it gets, everything just becomes conceptual. It's much, much harder. It requires a lot more energy. It's not so like automatic. It's interesting. Yeah. Anyways, yeah, happy to give any advice I can. Okay, but I did actually start on on uh, on an article, and it's kind of interesting. Let's see. Yes, I told it. Yeah, both models are brilliant, yet they each introduce their own kind of mental strain. Yes, they do. Yeah, it's actually a really good introduction. But here I need to go in and actually write the stuff I need to write. Anyways, yeah, for sure. Let's see. Got another silly question. I've been learning Python faithfully every day. I do tend to forget the syntax I learned when I'm coding the next day. Oh no, this is very normal. Yeah. Like you'll have that is very normal. And you're gonna have certain methods that you're never gonna remember. So in JavaScript, you have something called slice. And all engineers know has this issue. It's so difficult to remember how the slice method of an array works in JavaScript. And also sort is very hard to remember. Like, does returning one move which item up? Returning -1, does that move the item down? And which item does it move up and down? Like, these things are always going to be there. And in the beginning, there's so much new stuff that it takes a lot of practice to get it in. It's like learning any language, right? If you were, I would think about learning code as learning like an actual spoken language. And that takes time, right? So yeah, that's definitely normal. And there's always going to be words you just can't ever remember. Okay, what did it do here? Code review. Yeah, remove. Yeah, nice. Oh, remove redundant. Extract and flush. For instance, eliminate duplicate batching logic that depend. Okay. Added detailed. Does the test still? Yeah, for sure. Keep the questions coming. Okay, so the final thing we're gonna do here is push it, and then I'm gonna play around with the article. in the background, and then maybe we'll do a new stream. Yeah, because I don't think there's like anything more to really do here. Now we're kind of getting to the point where we would have to like try to build an app and stuff like that. But I'm not sure how exciting that is. Like the biggest challenge of any, like, which is insane that Solid was able to do, is like build up a community around it, because there's so much stuff that's like missing. Just take Tailwind, for example, that has like Vue and React components and any other UI library. You don't have that if you build like a new thing like Solid did. But then people like loves the approach and then starts building stuff and creates an ecosystem around it. And that takes time and it needs a shit ton of momentum. So yeah. And for me personally, like I don't have any ambition to like create a new thing. I just find these things interesting. And what's important to me is that the ideas are exposed, not like a library is adopted. Yep. The issue was that my didn't introduce it, but it revealed a pre-existing edge case. Okay, cool. Yes. So we're gonna push this. I'm gonna jump out of the stream. Git status. Git that. We can look at the README, by the way. Ready for review. Cool. And then let's see. There's a README here somewhere. Isn't there? Oh, didn't I add a README? Oh, there it is. Okay, let's see what this says. A lightweight reactive JSX UI library with fine-grained reactivity and automatic dependency. Inspired by React's component balance. Yeah, I guess that's true. I was almost thinking like maybe this should be the article. Reactive state. Push. Function props for reactive attributes. On mild, on cleanup, batched updates. Yeah, this comparison thing was really weird. How it works, yeah. Yeah, so we still had that index thing. Yeah. Anyways. Like, does this work if I just... If I just put that in here. Add to do. Yeah, I guess so. And then conditional rendering. Derived state. Yup. Yes. Best practices. Clean up side effects. Batch related updates. Cool. No, this is great. I think we're happy with this. Like, we could play more with it, but I'm not sure how much that helps. It doesn't really make any progress. Yeah. No, I'm gonna play around with the article and see where that leads us. Okay, cool. Thanks for following along. It was a little bit, I don't know, it was straining for me going through all these concepts and all this text. Like, this is why this is something I've identified with myself. I don't have the concentration to read a lot of text. It's very interesting. I think I've always had this. I just haven't truly identified it before. So like doing a stream like this, reading a ton of text and just talking conceptually is very straining for me. And maybe that's why, you know why? Maybe that's why my projects typically just drop, because when I have a lot of momentum is when I can like write code and look at things in pieces and like look at one thing at a time. But when I have to look at the whole thing, it's just so much. And especially if I have to translate all of that into documentation or articles and stuff like that, it's just straining for me. And then I get demotivated and then I drop the project because I have the most fun in the beginning. Yeah, I think that explains it. Anyways, we'll see how far we'll get with this. And thanks for the questions, Pasha. And maybe we'll see each other tomorrow. Okay, bye for now.